Welcome. In this video, we will see how to write a C program for 3D or three-dimensional scaling transformation. Scaling means changing the size of the graphical object. So in scaling transformation, we change the size of graphical object. We can either increase the size or we can decrease the size. So let us write a C program for this. Open Turbo C++, start Turbo C, create a new file, include header files, hash include stdio.h, hash include conio.h, hash include graphics.h. So why we are including graphics.h header file? Because whenever we are writing graphics program or whenever you want to draw graphical objects, then we must include this header file in our program, otherwise it will not give you correct output. Then our main function, inside the main function we will declare integer variable gd is equal to detect and gm. GD means graphics driver, and it will automatically detect which graphics driver we should use. That's why we have set the value of GD to detect constant. Then GM means graphics mode. So which graphics mode we are going to use, that will be denoted by GM. Then here we are drawing a three-dimensional object. We will draw this object using bar 3D function. So for bar 3D function, we require the variable x1, y1, x2, y2 and z. x1, y1, these are the x and y coordinate of top left corner of the bar or three-dimensional bar or three-dimensional cube, and x2, y2, these are the coordinates of bottom right corner of three-dimensional bar or three-dimensional cube, and z is the depth of that cube or depth of that three-dimensional bar. Then after scaling or after changing the size of the object, we will get new coordinates of that three-dimensional bar or three-dimensional cube. So for that we will require new x and y coordinates, new x1, new y1, new x2, new y2 and new z. Okay, so these are the new coordinates of our three-dimensional object after scaling transformation. Then we will also require the values of scaling factor Sx, Sy and Sz. Sx, Sy and Sz are called as scaling factor. This decides how much by how much value you want to change the size of the object. Suppose you want to change the size of the object by value 2 in next direction, then Sx will be equal to 2. Suppose you want to change the size by a factor of 3, then value of Sy will be 3. Suppose you want to change the value of object by a factor of 4 in z direction, then value of z you can take as 4. Then with the help of printf function, we will take the values of x1, y1, x2, y2 and z from user. For that we will display the message and z. With the help of scanf function, we will save these values. %d, address of x1, address of y1, address of x2, address of y2 and address of z. We will also take the values of scaling factor from user. So that's for that also we will display one message on the screen. Enter the coordinates of scaling factor Sx, Sy and Sz. With the help of scanf function, we will save these values into address of Sx, address of Sy, address of Sz. Now we will calculate the new coordinates. We will get new coordinates after scaling transformation. So how we will calculate or how we will get these new values using this equation? New x1, value of new x1 will be equal to x1 multiplied by Sx scaling factor. New y1 will be equal to y1 into scaling factor Sy. New x2 will be equal to x2 into scaling factor Sx. New y2 will be equal to y2 into scaling factor Sy. And new z will be equal to old z into scaling factor Sz. So you will see that we have multiplied each x coordinate with scaling factor Sx and each y coordinate with scaling factor Sy. Now we will use init graph function. We will pass parameter address of GD variable, address of GM variable and location of BGI file. Why we are using init graph function? Because whenever we want to draw graphical objects, our computer system must be in graphics mode. So with the help of init graph function, we can enter our system into the graphics mode. Syntax of init graph function is we have to pass three parameters. First is address of GD variable, second is address of GM variable, and third is the location of BGI file. BGI file is a graphics driver file and we have to pass the path or location of this file. So for example, in my computer system, this file is located inside C drive. There is a Turbo C3 folder and inside that folder there is a BGI file. So we have to write the path or location of that file. Now we will draw both our three-dimensional object before scaling and after scaling. So first we will draw our object before scaling and that we will draw in some different color. Suppose I will draw that object in green color. So I will use set color function and pass constant value green. And then I will use bar 3D function and pass parameter x1, y1, x2, y2, z and 1. x1, y1 these are the coordinates of top left corner of the bar. x2, y2 these are the coordinates of bottom right corner of the bar. Z is the value of the depth and 1 it is called as flag value. It means if the value is given 0 here, it means it will draw the bar without top surface, and if you give any non-zero value there, then it will draw the bar with top surface. So that is the difference. If you give 0 value here, our bar or our cube will be drawn without top surface, and if you give any non-zero value there, then our bar or graph, our bar or cube will be drawn with top surface. So that is the difference. So this bar or this cube we have drawn before scaling. Now we will draw the bar or cube after scaling. That we will draw in some different color. Suppose red. So I have passed red constant value to the set color function. Again I will use bar 3D function for drawing the bar or cube after scaling. Now here we have to use new coordinates. So write new x1, new y1, new x2, new y2, new z, and 1. So new x1, new y1, these are the new coordinates of the top left corner of the bar after scaling, and new x2, y2, these are the coordinates of bottom right corner of the bar after scaling, and new z is the new depth of the bar or cube after scaling. Now at the end we will write getCH function. GetCH function will hold our output screen till we give some input, and finally we will write close graph function. Close graph function, why we are writing? Because of init graph function our system is now in the graphics mode. To return back to the normal mode or text mode, we must write close graph function at the end of our program. So our program is now complete. Save this file, give some name, suppose p27.c. Okay, compile this program. Success, no error. Run this program. So enter the coordinates of x1, y1, x2, y2 and z. Suppose the value of x1, y1 is 50, 100. Value of x2, y2 is 100, 150, and value of z is suppose 50. Enter the coordinates of scaling factor Sx, Sy and Sz. Suppose I want to double the size in x direction, so I will give value of Sx2. In y direction also I want to double the size of the object, so I will give value 2. And in z direction also, suppose I want to increase the size by 2 or double the size, so here also I will give value 2. So now you can see this, the green color is our object or our bar or cube before scaling, and this red cube or red bar is after scaling. So you can clearly see that we have changed the size of the object. So in this way we can write a program for performing scaling transformation. So if you want to learn programming, then you can subscribe the channel. The program link is given in the description box. You can download and study the program. Thank you.